Okay, so this is another example. People had asked for some systems. So here's an example of two intersecting lines with some expressions for the angle measures. So if we want to set up a system of equations, we need to be able to generate two equations with two variables because each of these expressions have two variables in them. So we must use a system. So if I'm looking at this angle here, we'll call this, get back to my pen here. All right, so we'll call this angle A, we'll call this angle B, we'll call this angle C. So I know that angle A plus angle B equals 180 because they're a linear pair. I also know that angle A is equal to angle C because they're vertical, right? This is a linear pair, and this is a vertical angle relationship. Okay, so now that I know those, I can set up my system. I can say that 6x plus 3y plus 3x plus 3y will equal 180 degrees. At the same time, I also know that 6x plus 3y is equal to 3x plus 5y. Okay, so we're going to have to do a little bit of work here to be able to solve this system. Our options are either substitution or elimination. I believe elimination is going to be the best bet. So this first equation, right, if I want to rewrite this, I combine my like terms and I end up with 9x plus 6y will equal 180. Now if I want to get this equation set up, I'm going to go ahead and bring everything over to one side, right? That way I can have the formula in the same, or the equation in the same format. So I end up with 3x minus 2y is equal to nothing. Okay? So with elimination, you need to get one set of variables equal to each other with opposite signs. So since my y values, I have a positive 6 coefficient and a negative 2 coefficient, and they're already negatives, I'm going to go ahead and just multiply the whole thing by 3, right? So distribute that 3 there, and you end up with 9x minus 6y equals 0. So remember, you have to do it to both sides. You might see something like this if that makes it a little more comfortable for you. I multiplied by 3 on both sides. So that expression is now gone, and we have the equation down below. So if I look at this combination, right, 9x plus 9x is 18x, 6y minus 6y goes away, and 180 plus 0 is 180. That gives me a value of 10 for my x. All right, so now that I know x is 10, I can put that back into any of my expressions and find the value of y, any of my equations, right? So let's go ahead and look at the top one there, which is 9 times x plus 6 times y equals 180 degrees. So that gives me 90 plus 6y equals 180. So 6y equals 90 and y equals 15. So there I have both values, x and y. Both variables have been solved. Depending on what the question's asking, if I wanted to know what angle A was, then I would have to come back in here and say 6 times 10 plus 3 times 15, and that would give me 60 plus 45. So angle A is 105 degrees. Now if I had to find all the angles, C is easy, right? C has to be the same, so it's 105. B is the supplement, so I don't need to resolve this. All I need to do is just take 180 minus 105 and know that this angle has to be 75. You can plug in the values for x and y if you like, but that's basically solving a system using elimination. All right, thinking about those relationships up here, linear pairs, vertical angles. All right, you got to be able to set up these two very simple equations. All right, for a linear pair and a vertical angle, just a matter of doing the algebra after that. All right, hopefully this was helpful for you. Let me know if you have any questions.